Good morning. Welcome everybody to the game design workshop. We have people across a lot of different geographies today, and we're also streaming this live on Facebook and YouTube as well. So again, very warm welcome to everyone on a Sunday morning, Sunday evening for some folks, and I'm going to get started right away. My name is G Venkat, and I'm the founder and CEO of Bitwise Academy. We have a really packed agenda today, and we'll try to cover as much as we can. It's going to be hands on, it's going to be fun. So I'm assuming that everybody here has a laptop. We have parents as well as students who are here today. So please make sure that you just check your internet connection and make sure that your laptop is working fine, because there's going to be a heavy participation as well as a lot of hands-on examples we are going to try to go over today. So this is the general agenda. We're going to try to spend, probably at least two really good examples, of game design coding, if we are able to efficiently use this time today. So before I get started deeper into the presentation, a little bit about my background. I'm a scientist, educator, author, and a corporate executive. I did my undergraduate from the Indian Institute of Technology, IIT Madras, in aerospace engineering. I did a lot of research in the area of space shuttle engines, rocket propulsion, and also had a stint in the corporate world in terms of modernizing and transforming multiple industries. I love to teach, and I've taught students all the way from kindergarten to students in engineering, third and fourth year engineering students across a variety of courses. And the last 5 years, I've been using Bitwise Academy as a platform. I've been reaching out to the K-12 student community and been teaching a lot of courses that are geared towards K-12, both STEM enrichment as well as academic courses. Now, if you have your laptops ready, these are the two links you might need. The first link is essentially you can run the Scratch editor inside your browser. So if you were to visit scratch.mit.edu and then /project/editor, you'll have everything you need. What we need today is just that environment, and you're going to have fun coding within that environment. Now, if you would like to download and install the editor on your laptop, whether you have Mac or Windows, that there are downloadable versions of the editor available at scratch.mit.edu/download. They do not advertise the download link. So if you were to just go to the Scratch website, you're going to have difficulty finding where they have the download link. So they encourage everyone to use the online editor. It's going to look identical, so there's not going to be any difference between using the online editor versus the offline, downloaded editor. Of course, for convenience, if you download it, even if you're not connected to the internet, you would be able to use the same programs, wherever you are. And you can always download programs and save it to your local machine. You can also upload code from your machine to the online editor. So just make sure you have this environment set up, because over the next 5 minutes, I'm going to give some introduction. And while I'm giving an introduction and an overview, it would probably be a good idea to get your editor environment set up. So what are we doing today, right? We want to reimagine education. Today, education, is very academic oriented, and we have math and language skills right from kindergarten. That's where we get started, and then as you transition to middle school and high school, there are mandatory science courses, math courses, and variety of humanities and social studies and English courses, and various electives. If you were to take the traditional education and supplement that with STEM enrichment, then you're going to have success later on in your STEM career. And the earlier you get started, the better it is. Otherwise, the school system today is a cookie cutter system, right? Everybody with unique talents and skills go in, and then it's like a factory. It spits out cookies. Everybody comes out the same way with the same background, the same type of courses. So there is very little opportunity to explore and understand what really drives you as a student, what really excites you. And that's why it's really important to supplement enrichment, STEM enrichment, along with your traditional education, right? And that's what we've been doing at Bitwise Academy. We've been using artificial intelligence as a platform, as a technology weaved into our platform, and we personalize education at scale. We have won numerous awards in the past as one of the top AI companies in education. So this is just a little blurb. And what are some of the STEM tracks? Although today we are going to focus on game design, there are a variety of very interesting tracks that are gaining popularity. Of course, computer science itself as a traditional computer science subject, but also data science and AI, which you've seen with the Chat GPT. It's been all the hype. Then, of course, there's space exploration and biotech and 3D printing and Internet of Things. There are so many areas, and all of these STEM tracks are going to have very popular career opportunities. So it's important to explore these and figure out if you like these areas at all, and if so, try to enrich yourself as you go through your K-12 education. So now, before we actually start coding, I want to show you what's possible, right? Because today we're going to use the MIT Scratch programming language, the editor, the platform for creating games. Now, we're going to create really simple games today because that's all there is time for. But given time, and if you spend 2-3 months, really getting into it, I want to show you some games that are possible that were built in Scratch, and it's really, going to be eye-opening for some of us who have not really experienced games on the Scratch platform. Before we get to that, I'm going to hold that in suspense for a second. Just look at the history of how games evolved, because a couple of the games we're going to explore are what are called arcade games, right? So ping pong was or Pong was the real first game, the home game that was released, real oldie, a classic from the 1970s. Then, of course, you had Space Invaders and Pac-Man. Those were arcade games. Then what really, really put gaming on the map was the Super Mario Brothers when Sega launched that in 85. I'm also going to show you really quick, I'm going to show you a version of the Super Mario Brothers that has been built on Scratch. So it's really exciting. I'm going to show you a couple of examples of an arcade game and a platform game. That's what a Super Mario Brothers is called. It's called a platform game. And of course, the more recent platforms, gaming platforms like PlayStation and Xbox, and of course the VR platforms like the Oculus, they've taken gaming to a totally different level over the last 10 years. And that was all triggered based on the game consoles that started arriving, right? So that's kind of the history of the games. It's really interesting to explore if you're an avid gamer. Then also, what's important to understand are the genres of games. I'm sure all of us here have played a lot of video games, right? I've played a ton of video games. I continue to play. So of course you have the action, the adventure, the arcade, and so on. And there are other games like sports. Sports games are very popular, right? Racing, platform games. Some of these games actually involve a fair amount of physics. So really, there's a lot of different genres, and there is something in it for everybody, right? You start relating to certain games more than others. So that's the genres. And how do they all fit together? So here, this shows you how the games, all the different type of games fit together. And of course, here are the Pac-Man and the Space Invaders, the arcade, right? And of course, these days you have the shooting games, the platform games. That's where the Super Mario Brothers is, and adventure games and so on. And you can really see that it's a Venn diagram. There's a lot of overlap also between different games. But this is essentially, as you start getting into gaming, it's a good idea to understand because that's going to also help you design your games eventually. So without further ado, I'm going to show you a couple of games. I'll try to show you the Space Invaders and the Super Mario Brothers right now. there is time later on, I'll definitely consider showing other games as well. So let's see if I can get this quickly launched. Okay. I'm going to play it. Okay, I'm going to play this for like literally like a minute. Okay, so Space Invaders. So you see the power of a Scratch, how just Scratch can really create some amazing games. As you can see, you can choose, you can create, and you start the game. Right? Usually there is some way to trigger or start the game, and then of course you have, say press 1 to start, and this is a classic game. So you can actually go, and as you can see, the sounds are so realistic. So you see how realistic it is, right? This is really, and this has all been built in Scratch. Of course, this is not something that you'd be able to write in a day or two. It's pretty complicated, and as you can see, each of these, each of these elements is programmed, right? Each of these elements, and as you can see here, there are so many elements. These are just called sprites in the Scratch terminology, and it's all been programmed. And there are backdrops, and that's called a stage. We'll get to that in a second. But essentially, this is a pretty complicated game that has been completely written in Scratch. We also show you another really, really a powerful game, right? It's called the Super Mario Brothers. And let's see. Let's try Super Mario Brothers. I may have to load it. And this is another powerful game. Really fun to see this. And let's get this started as well. I'm actually playing this. Right? So it's really fun. As you can see, really, really super fun, right? This is like as you can see, it's really fun. If you start playing it, you want to hit all the levels, and next thing you know, you're going to play a couple of hours, right? So, but that's the power of, I wanted to understand, that's the power of MIT Scratch. You can build really complex games. It's not just a couple of cats moving around as you see in some of these projects. Of course, that's how you get started, right? You got to understand all the essential elements of how to design a game, and then it will take you a while to really implement that game. It's one thing to design it on paper or imagine it, and it's a different thing to realize that, where it actually starts working the way you imagined the game. But everything is possible, or anything is possible, using MIT Scratch as a programming platform to create games. Of course, as you get started with this, you'll eventually move on to other more serious platforms, right? Unity and so on. But to get there, you want to be able to first learn a lot of techniques, a lot of essential elements to game design. So I'm going to give, I'm not sure, how many of you remember Scratch and how rusty you are, or if you have ever used Scratch at all. No worries. Even if you haven't used Scratch at all until today, I'm going to give you a quick review of Scratch. And of course, when we do the examples, you might, may not be able to follow along at a fast pace, but then, you make notes. If you, one thing I would suggest is maybe get a notebook, get a pencil, so you can make some notes that you can come back to later after the workshop, and then continue to explore the Scratch platform, because I'm going to expose you to a lot of different controls, Scratch controls that you can drag and drop. And it's probably a good idea, if you're not too familiar with Scratch, to have a notebook and a pencil ready, so you can jot down some notes for you to visit those control blocks a little later, or those blocks a little later. All right. So what is Scratch and why do we use Scratch, right? So the Scratch environment looks like this when you download it. Now, of course, the latest version looks much better, where they moved the scripts, costumes, and sound all the way to the left-hand side, to the very end, and they moved this area, the actual stage. This is called the stage, where you see the cat, the stage, and then this other area below that. They moved that all the way to the right, as you can, you'll see shortly. So there's been some rearrangement of the interfaces, but otherwise, Scratch is the easiest platform to program on. It is a very easy to use platform created at MIT within their lifelong kindergarten group, right? So these folks just want to keep playing all day long, and so Scratch really allowed everyone in that group the opportunity to really basically bring out the inner kindergartner in you, so to speak, right? And then it became very popular. So today it is the most popular programming platform. It was so popular that they even created Scratch Junior to get kids who are as young as 5 years old involved in programming. So there's Scratch Junior for kids that are 5 years old. But then once you hit like 6, 7 years of age, you're ready for the real, the full Scratch platform. And why do you want to use Scratch? Because as I showed you, you can build very powerful programs quickly without having to type a lot of long sentences in. With normal coding, you got to type a lot of stuff in, and then then it involves using the keyboard and then going through a process called debugging, where it is really frustrating for a lot of beginners. When you start coding, you're going to make a lot of mistakes, and using Scratch, we kind of avoid all that. We just go straight to making things work right away. And so that's one of the reasons why I suggest that everybody start with Scratch, use Scratch. Then eventually, as you get more and more comfortable and understand all the concepts involved in coding, you can then graduate to other platforms like Python and Java and other things. Otherwise, Scratch provides you everything you need. In fact, there are Scratch extensions to even program your hardware, like your Lego Mind Blocks or other types of hardware. So you can also use that. You can add those Scratch extensions to the basic Scratch platform, and you'll be able to even control hardware devices. You can even get a Scratch running on a Raspberry Pi. So you can imagine that you have everything you need here in this platform to get you started started with coding, started with exploring a lot of STEM fields. And so that's why Scratch is a great platform. Why you should use it? I'm going to show you a really simple program, and in the context of that program, you're going to see what it is. What does it mean to program to the Scratch environment? So before I show you that program, I just want to kind of jog everyone's memory on XY coordinates. So, and some of you who may not have seen it, no worries, just kind of play along. So essentially, where your characters are going to move, right? In every video game, you're going to have objects, you're going to have characters, you're going to have something on the screen. In order to be able to move those things around, you need to give them an X and a Y value, okay? And in Scratch, the X value goes from a negative 240 to a positive 240. And the Y value goes from a negative 180 to a positive 180. And this area that where your objects are visible, where your characters are visible, this area is called the stage. And in order to be able to see the character at any point of time, that object or character has got to have an X and a Y value. That's called the coordinate for that point, for that object. So if you were to give it some number that is not going to fall within this range of negative 240 to 240 or negative 180 to 180 for the Y, then that object is simply not going to be visible, right? It won't make sense. So that makes it easy for you to control where to position that object in your game, and then also as things happen within your game, how to move that object, or where do you want to move that object, right? So from one position, let's say it's right here, where it is a negative 100. So this is a negative 100, a positive 100, where my mouse pointer is, as you can see. Maybe you want to move that object all the way from there to a positive 100, negative 100. Of course, the X comes first, followed by the Y. So this point would be where my mouse is now, would be a positive 100 and then a negative 100. Okay. So let me show you something you can actually write a simple program to actually determine where you are, right? Where is your XY coordinate? And let me load that program. And you can make notes, and you can also create a similar program. Okay. So it's just called the XY slider. And as you can see, it's a very simple program, and how do you build these blocks? Really easy. I'm going to show you here. Let's see. So you go here, and you're going to explore. I'm going to show you a couple of blocks that are super important. So if you go into events, and by now I hope you have gone to the online IDE that I had requested you to, or downloaded your IDE, right? One of the two you would have done by now. So if you were to go to the online IDE looks just like this, right? It looks exactly like your IDE if you downloaded it. And so it's basically scratch.mit.edu/projects/editor. And there you could do things like, hey, let me drag and drop this block, right? Which I was showing you. So essentially, you could drag and drop the when flag click block. Okay. You could drag the forever block. And this is something you can explore. Okay. So you can drag the forever block. Then motion, you can say, hey, go to a certain position. You can say, go to X and Y, right? So why not just kind of show you quickly? So you kind of just stack them, right? You stack them like this. And this forever, you want to keep going in a loop. So I'll show you what happens, right? With this, when I play this game, right? When I play this game, when I click the flag, so I can move the slider back and forth. And this, because of this, it's kind of not going to play. So if you look at this, now look at this on this side, right? Look at this little thing, how this crosshair moves based on whatever X and Y position I give it. So this is a nice nifty tool for you to have. So this is a simple program you can create for yourself as you design your game to understand where you're placing your object or character within the stage. So and how do you get this backdrop? That's pretty easy. I'm going to show you. So if you, in this environment, in your online environment, at the very bottom, it says choose a sprite. Okay. Of course, you can choose a sprite, and you can choose a variety of sprites that they have provided, right? These are already provided sprites. Or like what I did, you can just go and create a little crosshair. So you can go here and say paint. If you go to paint, it's going to give you a little paint area. Choose a line and maybe just draw your crosshair. So you can delete it. You can say I don't want that, and you can delete objects. You can erase them. You can basically, this is a little thing for you to create whatever you want. You can create a crosshair. That's a crosshair, right? I mean, you can take the time to create it of even length and everything. Essentially, you can create something, and then once you create the crosshair, you will select that, go to the code panel, and then once you're selected, you can also delete this cat if you don't want the cat, right? So this crosshair, and you can tell what size. You can say, oh, I only want 50% of it, or you can, choose the direction. You can turn it around, but in this case, if it's symmetrical, it won't matter if you turn it by 90 degrees or whatever degrees. And here is your X and Y coordinate. You can move it, let's say, to 50, -100. So it just moved. And you can go here next to the sprite, choose a sprite. You have choose a backdrop. Here, I'm going to choose a backdrop that already comes with Scratch, right? It gives you all kinds of backdrops. Go all the way down here to this XY grid. And now you see, you got your own XY grid, and you got your crosshair, right? So that's a way to kind of start, very quickly you can build your, scenery, how you want to look your scene to look at. So I went to backdrop, and I chose the XY grid, right? And then on the sprite, I just went to paint, and I just painted my own crosshair, just like that. And then you go to code, and then I got two sprites now. I can always delete the first one, goes away. Now, once that's selected, any program that I do, right, when anything I do here, will actually be programming this particular sprite. So if I say forever, and then you can choose motion, go to a random position. You can choose that too. So see, it's going all over the place. You see how it's going to a random position, right? You could do that. But if you did a random position, you wouldn't know exactly where it was. You could say go to XY, or you can say go to wherever you move the slider to, right? So you can put a slider and then say I added a slider, and then hey, put it wherever I want it to move to. And but if you want to do something fun, you can also, there is also a control where you can actually make it wait. So you can say wait, let's say 2 seconds. You do it randomly, so you go random, but then you can wait 2 seconds so you can actually see what's going on. So see, every 2 seconds it's moving randomly to a different position, and whatever position it's moving to, you can see over here the X and the Y value is being told. But this is literally a little fun program that you wrote to move your cursor randomly to wherever you want it to go. Of course, you can do what I did as well, is to essentially, instead of saying go to a random position, you can you can say go to a particular X and Y, and you can put a slider here, two sliders you can put, that makes it, then you can control the slider. Like here, you can control the slider, and then in that case it'll only move to the position you tell it to move. And so that's go to X, but then you can add a slider for each position from the controls that you might have in your environment. Also, another thing to note, in your environment you'll see that there is an icon right here. You can click this and you can add music. Then you have all these things that give you music, like playing a drum or playing a note. You can even have different instruments, so you can make it really fun. Or you can go to sounds, and you will be able to either record your own sound, or you can use any of the sounds. There are some sounds that come with it. You look here, it says choose a sound. Just like here you have choose a sprite, choose a backdrop. Here you have choose a sound. You can go here and you can record your own sound, or you can upload a sound that you have, or you can just choose a sound that is provided. The whole bunch of sounds that are provided. So you can actually, build, you can build characters, objects, your own, bring it from outside, design it, use something that they've given. Any and all, anything is possible. And then sounds. And what's a costume? I'm going to get to that in a little bit. Okay. When we do animations, I'm going to tell you about costumes. So essentially, it's really simple to start writing programs, and then put music, put various objects and characters, bring various backdrops. So I can switch the backdrop to a boardwalk, and boom, you got your cursor moving around, on a beach by a boardwalk. So there you go. So that's really easy to switch out backdrops and characters and objects and give it sound, right? So this, essentially, I wanted to show you a quick, view of Scratch, and I'm going to also walk you guys through couple of more things, right? Apart from just the XY coordinates, but this is key to be able to program a game. You need to be able to control the objects and characters and the scenery or the backdrop of your game at any point of time. Give it music, give it sound effects, and so on. And the only other thing left is animation and special effects, right? So those are also there. So we'll see that shortly. So of course, I showed you, just to recap, I showed you how to select a sprite from the given library or paint your own sprite. You can also try for yourself how to upload a sprite from your computer or create one from the camera. Sounds, I showed you, you could use the music blocks that come with, or you could create custom sounds by choosing a sound from the library, record a sound, or upload a sound, right, from your computer. How do you create an animation? So we're going to see that in just a second, right? So a sprite can be made. So the concept of animation here is what is called a costume. So imagine that an object, you're going to animate the object. One way to animate the object is for it to move from point A to point B, right? And that's going to be pretty easy to do. Scratch gives you various blocks to be able to do that. But also, let's say you want something to flap its wings, a bird to flap its wings. How is it going to flap its wings? Basically, it's like, a frame by frame, right? Imagine you have the position of the wing of the bird in like 4 or 5 different positions. It's all the way down to all the way up, and then a few positions in between. If you were to play all those frames really quickly together, it would give you the appearance that the bird is flapping its wings, right? So each of those frames is essentially a costume. So if something is running, something is walking, you could do it to make it realistic. Even if you were to move some object from point A to point B, it's going to look like it's gliding there without moving its arms and legs or without flapping its wings if you don't have these costumes to go along with. Because as you glide an object from one position to another, that object might have to be animated. And for that, you use costumes. Okay. And essentially, you have a costume block. You can change the costume a given number of times and then say next costume, and that would give you an animation. We might see a small example in a bit, but essentially, to create an animation, you switch the costumes associated with your sprite. A sprite is basically, like we said, right, an object or a character or anything in your game. And then if you switch its costume, you basically cycle through the various frames that are there for that same object. So a bird, for example, there could be 4 images for that same bird with different positions of its wings, and you play those frames together, it would look like it's flapping its wings. So that's just an example, right? So that's how, using the costume block and making it wait in between switching the blocks, you can bring in animation. Then another thing to note is a variable. So what is a variable? It's nothing but variable is some kind of imagine that it's some kind of a box that stores a value. And because it's a box, you can switch out the value. For example, your age, right? Today you might be 10 years old. Next year, that box that contains the age is switched out. Instead of 10, you put the value 11, right? Or in a game, there is a box that keeps score. Every time you earn points, you got to switch out the score in that box. Maybe you get 5 points for every activity that you do in that game. And so you got 10 points and then went to 15, went to 20. As you saw my Space Invaders, right? I was gaining points as I was shooting those alien invaders. So that's a variable. And it can also hold text values. It can hold numbers, text, and whatnot, right? And how do you create a variable? There is a variable, make a variable button, and you can give it any name you want. So, for example, in a game where you want to keep score, you would say name the variable score. If you want to keep track of count, maybe the lives, right? In some games you get 3 lives, right? In many games you get 3 lives. So you could have a count variable, and that count variable could track the number of lives you have left. As like in my Space Invaders game, if when I got hit, then I lost a life, right? So that's and you can imagine variables can be used for a variety of things where you want to keep track of either values or numbers or text and be able to change them as your game went along. Those values would go into what is called as a variable. Now, of course, there are also local versus global variables. For example, if the variable is only local to that particular sprite. So for example, if you are playing a game, and there are 2 teams, right? In a pong game, there are 2 sides, and you may want to keep separate scores for each side, right? How they're doing, right? Or you might want to keep scores for both sides in one place. So if you kept score for both sides in one place, that's a global variable, because each side might have to update their score. But if you decided to keep track of scores, each side decides to keep track of their own scores, then that's a local variable, because then it's not accessible. Your score is not accessible to the other party. So now there are some real world applications of this, right? For example, if you have a credit card, you don't want everybody accessing your credit card, right? So that credit card is local or your own, it's personal to you. So local can be thought of as personal, whereas global is basically accessible by everybody. So if you're playing a soccer game, that soccer ball is accessible by everybody on the field. It's not each team plays with its own soccer ball, right? That's okay during practice, but then that soccer ball is a global variable, it belongs to everyone. Whereas the shoes that you wear are local, it's personal, it's only for you, right? So you get the idea how to imagine local and global variables. Then a couple of quick concepts. We may not use all the concepts in the game today, but good to know. So I hope you have your notebook handy for you to make a note and then go visit this later. Now, imagine sprites or the objects want to communicate with each other. For example, right, you are playing a game where you're shooting something, and your projectile or your missile went and hit the other object. So now in a game, it's easy for us to imagine that, but in a game, you still have to program that concept. So you got to send a message that, hey, alien space invader, this projectile or whatever I fired already reached you or your neighborhood. So you're supposed to now disappear, right? So that kind of concept, how do you make in your program, how do you make that space invader disappear? Or you Super Mario Brothers, you made a jump and you hit the water, and so you lost a life. How do you detect that, right? So you broadcast messages between these sprites, and you basically broadcast a message. You can, and whoever wants to receive that message will be able to take action based on that message. So for example, the if you want the game to stop when you hit the water, you could have a message that says, the message, you can name the message anything you want. You could call it detect water. And then when Super Mario Brother hits the water, the Super Mario Brothers sprite sends out that message, hit water. Then the game itself could be controlling and receiving that message, and it might stop the game when the Mario hit the water. So essentially, it's a way for you to take action based on a certain event occurring. And actually, when that event occurs, you want to go do something else. So, for example, right, when you're watching a TV program, you're waiting eagerly for that movie to start, and right at 2 o'clock, let's say the movie starts, the minute 2 o'clock hits, the TV station knows to switch its program, right? And it switched to a movie that you were eagerly waiting for. And you were waiting for that broadcast, and you were waiting for the new movie to come at 2 o'clock. So essentially, messaging goes on, broadcasting and messaging goes on all around us all the time. And there are events that happen all the time. Now, you just want to bring that concept into your program. And I'm also going to say that there are a lot of graphic effects that come with Scratch. So you could change the color, and then you could also bring in things like, pixelate and whirl and ghost. And these are all like really fun graphic effects that you can play with. You can choose a sprite and apply any graphic effect to the sprite, and you'll see that happen. Then you can also hide and show your sprite. Sometimes you may want your object to disappear from a screen, from a scenery, then appear again later, and so on. So this hide and show and sizing it, making it small, making it big. So there are blocks for all that. So you can do that very easily. Then also detecting, like I said, right, we saw the color. You can detect two objects touching each other, whether a color is touching another color. You can also detect keyboard events. If you press something like, as you're playing the game, you want to fire or you want to make your sprite jump, all those things can be done by detecting what is called as a key pressed event. Or you can also detect if your mouse is being clicked. So all these can be detected again by blocks very, very easily. You would need all this in a game, right? So now let's see. I'm going to show you a game. Maybe you can try to play along with that game. Okay. So it's a very simple game. I'm going to have a bat that's going to flap its wings. I'm going to have a girl. The bat is coming towards. I'm going to show you a couple of so there's going to be animation using costumes. There is going to be movement, and there's going to be also the special effects, right? I'm gonna play this and then show you in a second, and then you can see how the code works for this. Give me just a second. I'm going to load this game. Not even a game. It's literally like 5-6 blocks that came together and was really fun, right? So I'm going to show you that. Okay. So what do we have here? We have the game loaded, and this has 2 sprites. So I've placed the bat. You can place it. I placed this bat, and there is code that is associated with the bat. Okay. And what about the girl? There's really no code at all associated with the girl. We don't need anything. The girl's sprite has been just placed. You can place it, move it wherever you want. And then there is a backdrop, right? I've created, to create this spooky, eerie look, I've chosen this dark forest. Now the girl has found herself in this forest, and there is this bat. Now you can imagine what this bat might want to do, right? It wants to scare the girl. So let's see. It says when clicked forever. So if you look here, right, when clicked, that's this block right here. And you may want to try to code this, right? Whatever you see on the screen, you might want to try to build that. So when clicked, then of course you have the control, which is forever. And then start sound owl. All I did was go to sound and start sound, and you can put other sounds, right? So this is the owl sound. So you see, since I said forever, it's kind of creating this sound forever, right? Otherwise, it would just do that one sound. If you put it in forever, it's going to go in a loop. So you can actually put other sounds. You can also do stop all sounds. Maybe you can do. So this is interesting, right? Let me show you something. So you can say. So what you can do is there is an event. So you can say when you do. So here is the broadcast messages. When I receive a message, you could do something. Yeah. So you can basically say, if some message I receive, you can stop a sound. Maybe the bat went to the girl, and instead of the owl sound, now the girl starts to yell or scream. So you could switch the sound, right? So or you can provide a button, or say clicking a stop or clicking a button, or you might stop all the sounds that are in your program. So it's up to you. You can use these blocks and control. But as you can see, it was so easy to build this block. You could also say, hey, go to XY, and then I'm going to show you this costume that I talked about, right? So this bat is actually available right here. So you could go here and search and say bat, and there's a different bat. See, you see the wings flapping. So this bat looks even scarier, right? You can add this bat. So this bat is even scarier, and you can say, I just want maybe 2 bats are flying towards the girl, making it even scary. This is a tiny bat now. I made it 20%, 20% size. Maybe make it 40% size, so it's a little bit bigger. And I could make that bat fly too by adding the same code, right? Take that. So you could add this code. Now, what does this code do? I'm just going to walk you through the code so you can drag and drop those blocks. Or if you want to go back and do this a little bit later, just make notes. So we want to, in order to make this bat fly, when you click the flag, we are asking it to go to a certain XY location, but then we are repeating every 10 steps. It's moving 10 times. So this is going to happen 10 times because it says repeat it 10 times. What is it going to repeat? It's going to move 30 steps at a time. Maybe the best way is to play this and see what happens. So as you can see, this bat flew all the way from its position. It started flapping its wings and flying towards the girl. And all the while you were seeing, hearing an owl or some kind of an eerie sound. Now this bat did not move because we did not program this bat at all. So it did not move. And the girl did not move. We did not program the girl. Maybe she wants to run away from the bat. You could program it, right? So all this did was, just with a few blocks, and then let me show you that costume, right? So um, if you choose the bat, and if you go, let's go to the costumes. You click on this costumes right here, you will see that this bat has two costumes, essentially one with its wing up and one with its wing down. But it was so realistic, right? When we played it, you see it looks like it's flapping. So it really looks like it's flapping. And that was just two costumes for the bat. And what did we do in the code? We just said next costume, next costume. And then we waited 0.2 seconds. The wait is another control block that's available. So you can say wait until, or you can say uh, um, um, uh, use different things. You can say if, or you can say repeat. So here I use repeat 10, and you can very easily, instead of 10, you can repeat it any number of times. Then I say show, then move 30 steps, next costume. So that means I'm just keep on, moving it from one costume to the other. And there were two costumes associated with this bat. So when I say next costume, if the wing was down, it would automatically go to the wing is up. But if the wing was up, the next costume would automatically go to the wing is down, because here there are only two costumes. Now if there were like five costumes, it's going to cycle through all the five when you do next costume. Okay, so it's important to understand what you're trying to do with the costumes. But in our case, it just gave you this animation, and this sound is going on in the background. Maybe there also I could put a wait, because with this sound, if I say, then you can hear the full owl sound. Maybe you wait 2 seconds. Okay, let's see what that does. Now you see how the effect changed. Now you hear the full owl because you give it 2 seconds for the sound to complete. So you have to play around with things like that, right? But you have this wait that allows you to wait. This wait just stops execution for that 2 seconds. Then it controls execution, but only for this block. So this wait 2 seconds has nothing to do with the bottom. This set of blocks. This is for animating the owl, right? Sorry, animating the bat. So this block is merely to animate the bat. And this top set of blocks here is to basically keep on playing this owl hooting sound forever. But now what we did, we added a 2-second wait, because if you didn't add the 2-second wait, it was just playing the first part of it, right? It's a different sound. Now you added this 2-second wait, you could play the entirety of that sound. So you can play around. Now, where do you get the show and next costume and so on? You can go to looks. If you go to looks, it'll say, see, switch costume. If you have multiple costumes and you want to control switching it, you could do it this way. So if you see here, you can switch it. But you can use next costume. If you want to play the next costume in a loop, then it just does next costume, right? So essentially, you can do this. Now, I showed you one thing, right? Look at the bat carefully. It kind of becomes like a little ghost as it starts to fly. It becomes white and bright. That's really scary, right? Now that is essentially this change brightness effect. Like I said, there were multiple effects, right? And you can also clear all the graphic effects if you want, but there are a lot of different effects. You can change the color. So how about we change the color, then the brightness? So we can change the color by 25. That means, I'll get to that in a second. So you see the bat goes from green to pink to red. If you look at it very carefully now, the bat is changing color. Changing color. So these are all the special effects. So you can change, make it pixelate, do various things to it. So you can change color, or you can change brightness. And this was all the effects I was talking about. A fisheye, a whirl, a ghost, and so on. So you can make it, into a ghost. So that's a ghost. It just disappears like a ghost. And so you can play around with your special effects, and you see, and I like the brightness as a special effect, but you can do that and you can change it. And this is just a quantity, a number 25. Basically, all of these quantities, like colors are represented using a set of numbers. All the colors to the computer are just a set of numbers for red, green, and blue. And when you mix red, green, and blue, you're going to get different colors, right? That's essentially how, if you've not done this, you should create a color wheel. And a color wheel is a fun way to learn about colors and how you perceive colors. Colors, what you perceive, the computer perceives them as just numbers, right? And so you use a number, to put it simply, use a number for red, green, and yellow, and giving a combination of these numbers, different numbers, would give you different other colors in between, right? The primary colors versus all the other secondary colors that are just a mixture of the primary colors. So you can do some, again, so you need to learn about colors, in which case you'll be able to apply that knowledge to creating different effects based on colors in your program, if you want to do that. But here, long story short, right here, these are just the two blocks that control the bat. The girl has nothing, and the backdrop is just the bow. The backdrop also, the sound of the crickets. So now this also keeps running. If you heard the crickets in the background, and we just use the crickets that are available from our, from the sounds that are available here locally. So I just added the pop and the crickets, and you can add that to your program using this choose a sound button, and then that's available for you to do select it in this drop down. When you say start sound, and then in this whatever sounds you've made available to your particular program, you can choose that from this drop down. So you can attach program small scripts blocks to every object on your on your scenery, right here, the backdrop, and you can change your backdrop. And then, of course, when you're all done, you can save it to your computer, and you can load an older program from your computer and continue to build upon it. So this is a really, really good example that brings in a very simple program, just like 7 or 8 blocks. It brings in a lot of concepts, right? It brings in the concept of when some event happens, some action gets triggered. So when you click the flag, you trigger the entire program when you click the flag. Then you have these loops that control your program, a forever loop. Here it's a repeat loop, right? A repeat loop repeats it X number of times. A forever loop keeps on going. Then we added sound. We animated the bat by making it go from one position to the other by moving 30 steps. And that's the motion block, making it move. You could also make it spooky, scary, and make it turn 15 degrees. So then it's going to rotate in the air. So as you see, it's kind of rotating in the air, and it just rotated out. It's just rotating all over the place. So you don't want that. So if you don't want that, then you can just take just that out and then put it back. But you could create a rotatory, so the bat was just rotating crazily. We stopped that. Okay. So that's kind of how you can play around. And then, of course, the wait allows your program, or that particular block will pause. So pausing and 2 seconds here in the first block has nothing to do with the 0.2 seconds here for the animation. Then there are special effects, and then of course cycling through the costumes. So just knowing these few concepts, you were able to create a really good effect of a bat scarily flying towards a girl in a forest, and all these sounds, eerie sounds, and then animating this bat, and it is essentially becoming white as a ghost as it comes closer. Okay, so that's kind of we went through a lot of stuff so far, and built a couple of programs. Now we're going to actually design a game using all these all these concepts that we learned. Let's see if we can build a Pong game today, right? So that's the next lab. So I'm going to give everybody a couple of minutes, because we get started with the Pong game, we don't want to stop, right? So that's going to be a good 40-minute lab. So because we've been at it for about 55 minutes, just like in your school, right? I'm going to give you guys a couple of minutes break, so that if you want to stretch your legs, move around, and come back in 2 minutes, we're going to build a Pong game. I'm going to teach you all about game design. How do you design a game from the ground up, and then how do you implement that game? So we're going to see that from scratch. We're going to design a game, and we're going to implement the Pong game. And again, we can achieve a lot with just a few blocks. So don't worry about how are we going to build a whole game in 40 minutes. It's going to happen. We're going to build a game in 40 minutes. There might not be time to build other games like Whack the Witch and so on, but I'm going to give you some homework. So when we get to the end, I'm going to leave you with the homework, which would be to do this game design. I'm going to show you how that game works. It's a really fun game where witches are flying around and you click them and they turn into frogs. And in a couple of months, you have your Halloween coming up. So it's a fun game, and it might take you several hours to build it. So I'm going to give you homework when we leave, but before that I'm going to show you how to build the Pong game. So take a couple of minutes break, and I'll see you back in a couple of minutes. All right. Okay, we are back. That hopefully that allowed everybody to stretch their legs and then get ready for this next session, which is going to be designing a game from the ground up. And also, I hope if you were still working on getting your project environment up, I hope everybody's now been able to get their project environment up. And so looking forward to this session. So we're going to get started right in about 30 seconds, right? Let everybody settle down. And again, I encourage you to have a notebook and a pencil so that if you, are doing it for the first time and, are not that familiar with Scratch, maybe take a note, make a note of, what blocks we're using, so that you can go back later and take your time after the workshop, take an extra hour afterwards, and then kind of figure it out where these blocks are. Because I know that if you're doing it for the very first time, it can be confusing, it can be overwhelming. But believe me, this is one of the easiest programming environments, or if not the easiest programming environment. So even 5-year olds, once they get familiar with it, are able to drag and drop and code it, right? It's so much fun. It's so logical. It's just, if you, and most kids today, all of you operate a smartphone so easily. So just a matter of time, you try this, keep playing with it, and you'll know where everything is. Initially, it's just a question of knowing where everything is, right? So as we're getting started, and as people are, kind of settling in, just wanted to call out this environment, right? Projects editor, scratch.mit.edu/project/editor. Whatever projects you create from the file, you can save it to your computer, give it a name, save it to your computer. There are tutorials over here if you want to kind of play around with some of the help and the tutorials. The sprite is where you choose your sprite. The backdrop is where you choose the scenery or the background, and you can add extra music and drawing with a pen, and you can add other cool things, video sensing, text to speech. And here is what I was talking to you guys about, Lego Mindstorm. And there are a lot of other extensions to Scratch, not the standard extensions that MIT provides, but also there are extensions that others have written. So it's really a fun environment. And then, of course, costumes, where you can create costumes, choose a costume, or sounds. So really a very, very flexible environment, right? So let's park that for a second and go back to where we left off, where I had given everybody a good overview of Scratch, and then we had written or basically looked at this little game, a hands-on fun. In about 5-10 minutes, we were able to build animations and special effects and sound and almost all the pieces you need for building your own games, right? We kind of saw that, and it wasn't that difficult. So let's talk about design, right? So I'm going to break this into two parts. First of all, discuss the game design. How do you approach, you have idea for a game. How do you translate that idea into something that you can actually build, right? So that is called design, game design. So you got to go through the design process. You got to go through design thinking. You're going to hear a lot of different words like this, right? So this is nothing but taking your idea and documenting that idea so that you're able to articulate that idea to yourself or to other people. Basically, how can you explain your game before you start programming that game, right? So that's essentially game design. So we're going to take a simple game like Pong. Pong, we can, this is our own take on Pong, right? Typically in Pong or ping pong, you have two people, right, playing against each other, and the idea is that there is a ball that's being hit between the two parties, and if you fail to hit it or hit it out, then you lose a point, right? So this is our own take on Pong. So you're going to see a little bit interesting here. So what are some programming concepts? For your game to become alive, you need to understand a couple of concepts. One is that your game models real world objects. And when you say real world objects, the objects can also be characters or animals or trees or anything, right? Objects, it could be animate or inanimate. And all objects contain what are called state and behavior. So what are these two terms? Let's look at it, right? Let's unpack that. So you're a student, right? And a student has a name. You live at a certain address, you go to a certain school, you are of a certain age. All that is state. That's called state, or basically your attributes, your characteristics. So somebody's name. So there is John, who lives in California, who attends a certain school, is 11 years old. So that's the state or the characteristics. Similarly, right, all objects, right? You have a pencil case. The pencil case could have a zipper or it's just a lid, and it could be of a certain color. Those are the characteristics or the state of that pencil case. Or you have a dog. The dog could be a certain breed. It could weigh a certain pounds, and it could have hair, or it may not be as hairy. It could be, the dog could be certain months old. So again, dog has certain characteristics. That's the state of the dog. What's behavior? Behavior are the actions that or functions that are associated with that object. So a student can sleep, can eat, can study, can play. If you take an automobile, a car, you can drive the car, you can accelerate, you can stop the car, you can honk. So those are actions or functions associated with the vehicle, with a car. Now a plane is also a vehicle, but might have different functions, right? So some objects can derive certain characteristics from a parent object, but might also add its own characteristics, right? So every vehicle, is able to move or take a person from one place to the other, but they do it differently. So while you might have a function called move associated with a vehicle, depending on the type of vehicle, a ship might take you on the water, an automobile on land, and an airplane in the air, right? So the behavior could be similar but could also be different. So that's basically, you need to start thinking about what objects, animate or inanimate, are going to be in your game, and what kinds of state they're going to have, what kinds of behavior you're going to associate them to, and is the state going to change? A lot of times the state can also change, right? If the state is you're tracking, the speed of the vehicle, then that state changes. That's a variable then, right? That state is not something that is final and fixed, but it's something that varies. So you'd want to capture that state in a variable and say, the speed of my vehicle is going to change during the course of the game, right? So basically, you get the picture that you're going to have state and behavior. And these objects we already saw, they're called sprites. And you store the state in variables, and you provide the behavior or expose the behavior of that object through the blocks. We have been dragging and dropping blocks, right? You can think of them as scripts or logical, code that executes, right? So that's how the behavior is expressed or exposed to other sprites. You may want to have a button, and you click a button and then something happens. So that's that object exposing its behavior through a button, and you clicking the button triggers that action or response from that other object, right? So that's why behaviors can be expressed or they can be exposed for other objects to invoke it or act upon that behavior or trigger that behavior. So you got to understand some of these concepts as you design the game. Then of course you got to think of graphics and sound effects. What effects are you going to create in the game? And also think of pre-designing your own backgrounds, right? You don't have to use the backgrounds that just come with Scratch. You can design your own backgrounds and graphics and sound. So then that becomes a very unique game that you created with your own everything effects from scratch. So these are some of the game programming concepts, and you got to write this down. You got to capture it, right? You got to capture this down. How do you capture this? You can make a note of this. I call this my game design project planning template, right? It's a template. So I decide what my stage design and layout is, all the background and the graphics and everything I design. Then I decide on what this. So I design. So basically, decide your scenery or your stage first. That goes in the middle. Then on that stage, you're going to place sprites, and you got to decide what are these sprites, what are these objects, what is the state and behavior. Are they going to have costumes for animation? And then the backgrounds that you're going to apply. Sometimes you will switch backgrounds. For example, if your game has multiple levels, each level can have its own background, right? So you're going to switch backgrounds. Or in the case of the bat, the girl starts running and comes out of the forest. Maybe the forest background changes to maybe something with a river or a water or something else, right? So you can think of switching backgrounds upon some action occurring. Then you have your variables like age, name, score, level of the game, sounds and music. And if your objects need to exchange messages with each other, what are those messages? How are those messages going to get triggered? And if you broadcast or receive a message, what's going to happen, right? So that's the messages. Then you just assemble logical blocks that execute your vision for the game, right? So This is basically your game design template. Make a note of it so that you don't miss anything on this template. You're going to need all of this, to design a game. And the good news is this is all you're going to need to design the game. Everything else, all the blocks and everything else you see in the Scratch environment kind of fits into one of these boxes. Okay. So if you go through this methodically and think about your game, you will be able to design this. So this is essentially the part of game design. Once you do this, then you know what you're going to write. So initially, the logical blocks, you just write it in plain English, what you expect to happen. Taking that English, and by the way, that English written, in nice steps, it's basically called pseudocode, right? It's not the real code, it's pseudocode. Then it's easy for you to take that and translate that into actual Scratch programs or scripts. So for Pong, let's attempt that. This is a simple table, just to give you an idea of how you can take that and write it down. I said, hey, in my Pong game, there is a paddle. There are no costumes because the paddle doesn't flap its wings or change. And what am I going to write? The paddle is going to move, right? So one of the actions or behavior of the paddle is to move. And I'm writing a little description. When I move the mouse, I want the paddle to move in the same direction. But I do not want the paddle to move all over the place. I want the paddle only to move horizontally. So horizontally means the x-axis, right? So I just want it to move horizontally so the paddle can move horizontally. So I kind of already am telling you how my game is going to be, right? That means the ball is probably going to bounce off of walls and the ceiling, and the ball is going to come down, and I'm going to move the paddle along the floor, and I'm going to bounce the ball back before it hits the floor, right? That was the concept. Now, there is, of course, the ball itself. No costumes again, but the ball is going to have multiple behaviors. So there is a start. When the game starts, I want the ball to drop from the top. That's a behavior in my game, right? Your game, it could be different. The ball comes from the side or wherever, but the ball's got to start. Or you randomize it and say the ball is going to randomly appear. As long as it's not appearing from the floor, then your game is good, right? Because why not from the floor? Because I'm saying there is a behavior stop the game when the ball touches the ground. So I don't want the ball to appear from the ground because the game would not even start, it'll just not even get started. Then if the ball hits the edge here is basically the walls or the ceiling or whatever, right? So that's the edge. If it's edge, then I want it to bounce, because if you throw a ball on the wall, imagine it's a ball made of rubber and you throw it, it's going to just bounce around, right? Elastic, right? And then of course, if the ball hits the paddle, then I want it to bounce off the paddle at an angle. Now this is important, right? Sometimes in your game, to be realistic, how would it be that the ball hits the side of the paddle but it's still going up to the ceiling? That's not realistic. If it hits the edge of the paddle, it's going to go off at an angle. Or if you apply some momentum and you kind of move the paddle and the ball hits it as you're moving the paddle, that's going to be different than if the paddle is stationary and the ball hits the paddle. So there might be some angle at which the ball comes off the paddle when it bounces off the paddle. Again, you might choose to create your game, initially without considering the angle. Then eventually you might add that to make it more realistic. Again, it's totally up to you. But what I would encourage is the more math and physics you kind of learn and you add. Now imagine, the concept like gravity, right? You're going to jump, and if you jump, you're going to fall back, right? When you jump, you're not going to keep going 100 feet in the air, right? Of course, unless you're designing a game with some superpowers for somebody, right? Then that's different. But then in general, when an obstacle is thrown, and again, if you haven't played the game called Donkey Kong, it's an arcade game, a platform/arcade game, really great game, Donkey Kong, that has a lot of jumping and dodging obstacles, and it's a fun game to play, to learn. Again, it's a great game to learn game design, how they designed many of these arcade games. If you play it, really classic. They put a lot of thought into game design, right? You learn a lot about game design when you play some of these arcade games. So here, to bring the realism in, you might want to incorporate some math and physics. If not immediately, in later versions of your game, as you learn these concepts, you can bring them in. Now, I'm also going to have a sidewalk, okay? There is not going to be any function associated with the sidewalk. It just exists to detect if the ball missed the paddle and hit the ground. And there is a backdrop, which is a walled area. So a wall is realistic. If I don't have a wall, how is the ball going to bounce? It won't be realistic if there is nothing there. So I'm just creating a walled area. Again, you design your game, right? How you want, but this is essentially the thought process that goes into basically putting the whole story down. Then that allows you to visualize your story and make that come to life when you start programming. So this is kind of a little way to describe, so you go from the template to something like this that allows you to understand this. You can now take around and talk to people, right? Hey, this is my idea for the game, this is the story, right? And then you might get some input, and or you might choose to take that input, ignore that input. It's your game. Ultimately you decide how you want to program. And believe me, if you program the game, you can always win. You can score 100 points, and you can put some special tricks in your game that you don't need to tell anybody about. So when you play the game, you're always like scoring these high points and knowing what to do. And somebody else plays your game, they got to learn the hard way to learn and play it, right? So you could also do that. A lot of game designers do that. They put a little couple of hooks or tricks in there that only they know about, like a special keystroke or a special thing that they click or do something, and the game behaves a little differently to make it easy for you. I'm not suggesting that. All I'm saying is that a lot of game designers do that, right? They put some little hook just to put their mark on the game. They hide something in there. So now the next step is to translate that to what blocks you're going to use. So if this is all the behavior, so let's recap, right? So you have this template and you're going to design this game. And as you design this, you're going to describe the game in plain English about the sprite or the object, the behavior associated with it, the costumes, the scripts, what it needs to do, and then describe it. Now you need to associate that with the Scratch environment. What events are there? So when flag clicked, so when I click the green flag, you could also, like the Space Invaders, if you remember, it said click the number 1 to get the game started, the Space Invaders started. It doesn't have to be always the flag. You can decide how you want to start your game. Or you can even provide a button and say, if that button is clicked, you could send a broadcast message to start the game, right? So you could do whatever you want. Motion, we are going to go XY to an XY. We're going to point in a direction. Turn, we're going to bounce. We're going to move 10 steps or 20 steps or whatever at a time. We're going to set the X value. We're going to play some sound. Then we're going to have all these controls forever. So certain things are going to go on forever. Certain things are going to happen if a certain condition is met or if a certain condition is true, right? For example, if you're hungry, you're going to eat, right? If it's 3 o'clock, the school bell is going to ring, right? So there are certain conditions that are associated with some event and it's true or false. Then you might want to stop the game. Then sensing, right? So if you want to see if you touched a certain sprite, so if your ball touched the paddle, so the ball sprite is touching the paddle sprite, two sprites touching each other. Or a color, when it falls on the sidewalk, the ball falls on the sidewalk, you can detect the color of the sidewalk, and if that is true, you can stop the game. Or you can detect if a mouse is being pressed. And then I could pick some random events during the game. So again, all this kind of shows you these are all the blocks that I need. That's all I need. I don't need anything more than this. So literally a handful of blocks and you're going to get a Pong game. Isn't that unbelievable? Now let's now go and load this Pong game. I want to show you how it works. Then we can go about building it for the rest of the session. So Pong starter, I think. There you go. So this is my game, the Pong game. And you can see that there is a sidewalk, there is a ball, there is a paddle. And let me start the game. And if you remember, I said the paddle, I've programmed it to only move in the X direction horizontally. Now it's moving on the sidewalk. And if the paddle misses the ball and it goes, hits the sidewalk, you're going to stop the game. And then you're going to bring in realistic sounds, right? When the ball hits the paddle, and then you can see it bouncing off the wall. So let's see. As you can see, the angles, see, that's very realistic, isn't it? See how I make it move in any angle, the direction I want. And if I don't do anything, it's just going to bounce straight off. And if I want it to bounce, I can actually make it go at different angles. Now it just stopped because I did not move the paddle. The game came to an end. As you can see, really fun game. Now you can make it differently, right? You can create all these bricks into different sprites, and then you could make bricks disappear, right? If you've seen some games where the ball hits the brick, that brick disappears. Then you're going to create a more fun game where if you have a layer of bricks and you kind of take out a couple of bricks, the ball could squeeze through, and maybe it's bouncing up and down between the top ceiling and some brick and then comes out, right? So you could make it a lot more fun, and then you could keep track of points. Every time you hit the paddle or you hit the brick, you could get points, right? So you could but this is a really a simple game, but it's a little bit more complex than what we saw before. Okay, I put some comments out here for you to see. And here basically we have the paddle. The paddle is very simple, that's not much. And then you have the ball, and then you have the backdrop. And again, in the backdrop, there is nothing going on. I just went, to the backdrop, and I just chose the brick right here. I could also choose wall too, but that's the grass. It's up to you. It won't make. Or you could choose your house, play in your room, right? You could do what you want. Again, these backdrops come with. So I just used the one with the brick wall that already came with it to make it easy. So if you want to build this game, all you got to do is go to the backdrop and then choose that, and first add your backdrop. Just add that wall, and don't click back. Okay, you have to click it and say okay. I just clicked back because I didn't want to add two versions of it. If I did this, then I added this backdrop, right? So we don't want to do that. Let me go back and add the wall back. Okay, so then let's program the paddle. And how do you program the paddle? Use the when flag clicked, the forever block, right? And then let's see if you know where to find the set X to mouse X block. This is two parts, right? There is no such block that says set X to mouse X. As you can see, they give you some color coding, right? You have a dark blue and a light blue. So the dark blue is motion, right? You see the color, the colors are very easy for you to relate to. So it's a motion block. So the motion block here, set X to. But what this does is it set X to a fixed point. You don't want that. You want it to kind of track the mouse. So you want to sense where the mouse is. So go to sensing, and there you see mouse X. There you go. So you drag that, and this is a variable. The mouse X is a variable that is provided by Scratch that always tracks where your mouse is, tracks the X location of your mouse. So if you set X to the location of the mouse, then you know that always wherever you move your mouse, that's going to track and set that sprite to that where your mouse is. So the paddle, since you're attaching this logic to the paddle, what it essentially does is wherever I move my mouse, the paddle is going to go to that same location. See, the paddle is going to the same location. And now you see it's not going to drop. Why? Because it keeps bouncing from the floor. And why is that? Because if you remember, I changed my backdrop. I have 4 backdrops now. And as you saw, I kind of added, I added this wall again, but I lost the detection of the red color. So I had done that. So here I had said that if the ball, now you see the thing, I said if the ball was touching the red color, I was telling it to stop. So, but since I took out that, that red floor, now the ball does not stop, but it keeps bouncing. So, but I could do this. What I could do, I could go to my paint, and I could create a block, and I could say put red color on it, and I could put that here. And now you suddenly have a red color to detect. If I play this now, maybe it's the exact hue. You need the exact hue. So that's why it's not. So this red color, it's got to be this red that you've chosen. If you go to the code, so everything's got to be exact. So this red color, so it's got to be this. So that's where I told you about the numbers, if you remember. So here it says color, brightness, saturation. So you got to make sure that you are choosing the exact values for it to detect the red color. This seems like a little bit lighter red color. So you could also do that. If you want to choose this lighter red color, then you could change this to that, and then you might be able to detect that. So it's got to be exact. Everything's got to be exact. Otherwise, it'll behave differently. So that's how we are able to essentially start this program. So let's go back to the paddle. Let me just delete the sprite for a second. So go back to the paddle, and I hope you got this program down for the paddle. So now if you have this down, where you have the flag clicked and a forever loop where you set the X value to wherever the mouse is, if you did this, then there is no ball, but you'll be able to move your paddle left and right. You'll be able to move your paddle wherever you want. So that should work. Without the ball, the paddle, you should be able to make it work. Okay. Next, you can add the ball sprite. Let's see if there are any balls over here, right, in the sports. If you go here to the sport, whatever they provide you, it doesn't have to be the ball that I had, right? You could put a tennis ball. So now you have the tennis ball that can bounce. So whatever the code I have for this ball, you could choose the tennis ball sprite and do the same thing. Then in your case, the tennis ball will start bouncing around, okay? Because in your environment, only the tennis ball or these balls are available. So you got to go with what you have and pick one of these: soccer, baseball, basketball. You got to pick, or you could create your own, like I did, right? You could go to the you could go over to designing your own sprite paint, and you could kind of create your own sprite and put some effects there. You could say, so then that becomes your ball, right? So then your ball can kind of move around, bounce around if you add the logic to this ball. So it's all up to you, how you want to do this. And if you have the time, you could even create it in an outside program, and then you could say, I'm going to upload it. You could go here and say, hey, I'm going to upload the sprite from my computer, and then you can have characters. You can design your own characters and whatnot, and costumes in other programs that are outside the Scratch environment, which might be giving you a lot more flexibility to designing things. And then you can upload that. And then when you upload it, then Scratch will bring your sprite from your computer into the program. And then you can write the program associated with your own sprite. So that's also possible, like I did with this ball. I created like a little fuzzy ball, and then I have program associated with this fuzzy ball. Although the paddle, now I might have chosen, the paddle was simple. I just used the drawing paint, and I created a paddle. That's easy to create, right? You could just go here and you could draw a little paddle. You could delete that. You could choose this, and you could draw a little paddle, however you choose to draw. Or if you want thickness, then you may have to draw a paddle like a little rectangle, but you make it a thin rectangle. And you could also have the paddle a different color, right? So that's your paddle now. Okay. So it's up to you how you want to design these things. You can always delete it if you don't like it, and so on, right? So now you should have, I don't want to have two sets of this, but basically you should have programmed the paddle. So that, see, the paddle, if you look at it, I didn't even start the game, but you move your paddle, you move your mouse, the paddle is tracking your mouse. You could also make it more fancy by providing the left and right arrows. Instead of the mouse, you could actually say, not when the flag is clicked. You could say when I press the key. So in that case, you would detect key presses, right? You could say if this key is pressed, then you do certain things. So in that case, so you can say when you could decide which key. The up arrow, you could say, so here in the events, you're detecting an event. The event is a key press. So you could say if my right arrow is pressed, then you can put all this logic of moving the paddle to the right, but you have to put all the blocks associated with it. Then you could have a totally different block and say when my left arrow is pressed. So let's do something fun, right? So when my right arrow is pressed, let me say I'm gonna move wherever I am. Let me move like 50 steps. And then when my left arrow is pressed, I'm going to say glide to this location, right? So now let's see. I'm going to press the left arrow, and you see how the paddle, when I press the left arrow, it just was gliding, and then when I press the right arrow, it just moved 50. I could also put another glide and say glide to a random position. So now I pressed my right arrow, it's gliding randomly. Pressed my left arrow, it's gliding to this, right? So you could really, so it was so easy, just 2 blocks, and you were now able to control your paddle to, now obviously, instead of gliding and randomly, you would actually move, 10 steps. Each time you hit the right paddle, you could say move 10 steps, but you got to say, and then here you could say move minus 10 steps, right? Minus 10 would go into the backward direction. So let's see how that works, right? So you could attach left arrow, right arrow, and so on, and you could make it move by adding. You could do other things associated with arrows. So very easy to attach different behavior based on certain events occurring. Or when you click the sprite, when I click, let's say when I click the ball, when I click it directly, do you want it to produce any sound? That would be funny, but hey, why not, right? You could play some sound, whatever sound you could, bring in a sound, and let's see what sounds are there, right? You could add a sound and say I'm going to play a saxophone, and that's the sound, and I could play a sax when I click the ball, right? When a sprite is clicked. So you start the game, then you can make it a little hard, but you can make it play a saxophone when the paddle is clicked, right? So if you see, I click the paddle. You also have to be very careful to which sprite you're attaching the behavior. I click the ball, nothing happens, but I click the paddle, it plays a saxophone sound, right? When this sprite is clicked. So you can put a lot of different actions. You can detect a lot of different things going on in your environment and make it fun, make it quirky, make it your own, right? But just here right now, I move the paddle, and all I'm getting is, I'm able to move the paddle. That's it, right? Now, let's now go to the ball. This is a little tricky because it has multiple parts to it. And we do have half an hour, right? So we're going to build this. It's not going to take that long. So let's see, right? What do we want to build here, right? Basically, you want to type a bigger number to make the ball go faster. That means if you want to make the ball go faster, instead of moving 10 steps, if I put 20 steps, the ball would appear as if it's going a lot faster. See? So you could have different levels in your game where you speed up the ball, right? You could speed up the ball. Now, what happens if I put like 50 steps, right? It's going to be crazy. You're not even going to be able to move the paddle. See how fast it is? You want to be able to move the paddle. So 10 was reasonable, I thought, where the speed was, something that you could move the paddle. Again, you could make it faster and faster. You could have different levels, and make it faster so you could control it. So how do you get the ball to move? So go back to the events. When flag clicked, then these look like dark blue. So they are motion blocks. So you want to go to a certain X and Y. And I started with 2150 so that every time it always starts from the same location. That's why. So you see, it always starts from the same location. The ball drops. You can randomize that also if you want. And then it's always coming at a 45-degree angle. So if you look at it, the ball is going to start always from the same place and come at a 45-degree angle. Right? Now I could change that. I could say come at a 20-degree angle. And see, it shows you where it's coming from. You see this nice thing? So you can actually use this control and you can set it, or you can just type it directly. So now what happens? See, the ball came only at a 15-degree angle. 15-degree angle from the vertical, okay? So it's not 15 degrees from the horizontal. If you look here, it tells you from the vertical, right? From the vertical, it's 15 degrees. So if I were to put 90 degrees, how is it going to come? See, it's only there. 90 degrees from the vertical, it's just going to go back and forth. It's not even going to come, right? So you can play around with it, and that's why I put it at a 45-degree angle. So it's going to come right from the vertical. It's a 45-degree angle. So it's going to hit the wall and it's going to bounce. It's all part of your design decisions, right? Some of these you might not exactly write down to the nth level of detail when you design it, but you would have to think through it. Imagine it. Hey, how is the ball going to bounce? What angle? And then sometimes when you're coding, you might have to give it a shot, try a couple of different things there, right? Then of course, right, you want it to point in a direction, and I don't want 90, I'm going to put 45, right? And that was also, all these are motion blocks, right? Now for forever, you go to the control and you bring the forever. Then this is the interesting thing. How does the ball know to bounce? How does the ball know that it has to bounce? Very simple. There is a block called if on edge bounce. So they've given that to you because they know that the stage is limited. They know that your objects are going to hit the stage if you move them. So you can just drag if on edge bounce, drop it here, and what's going to happen every time? If you want to keep the ball moving continuously in the direction in which it's already moving, you can say, hey, move it always 10 steps. If you want to slow it down, you can move it 5 steps. You want to move it down, if you want to make it move very slowly, you can move 5 steps. Otherwise, you can make it move 10 steps, right? So that's essentially, so how slow it moves, right? Moves very slow. Let me go back to 10. There was a more reasonable speed. And as you can see, I put 50. You can't even see. 100, that's impossible. Okay. So 10, let's stick to 10, right? So I hope everybody got this block down. And here I put this note. Bigger number makes it go faster. Why? If you have multiple levels, each level you can increase the speed by 10 by just making it move faster by moving its steps by 10, 20, 30, and so on, right? So I hope everybody got the gist of this one, because this block is what is giving that function or behavior to the ball to bounce around. Remember, we said it starts and then it bounces. That behavior that we described earlier in the game design, that's what it is. Okay. Next, let's attach additional behavior, right? What other additional behavior do you want to attach? There are a couple of behaviors you want to attach. One is, when it hits the floor, you want it to stop. And before that, you want to touch the paddle, you want it to bounce, right? So how do you do those two? Those are essentially also two behaviors that you need to program. Now, this is just a post-it, right? You can add a post-it. It's a comment. They call it a comment. It's not going to interfere with your game logic at all. It's just a note for yourself or to convey to other people. So here, you go back to your when flag is clicked. And then you're going to put everything. The whole game is in a forever loop. It keeps on playing. So it's going to be a huge forever loop, right? And as you keep stacking blocks inside, and then in the forward loop, there's a huge if, then else statement. What is that if, then else statement? Because you want to know if the ball is touching the paddle right away. And the touching the paddle is basically a sensing event. It's a sensing. So you go here and you want to see, and the decisions, right? All the decisions are in some kind of a diamond. You see this? This is like some kind of a diamond shape, right? It's like a little hexagon. So touching the mouse, touching the color. If color is touching color, you can also detect your distance to the mouse pointer from wherever the sprite is. Because sometimes you may want to know that, right? So there's a lot of interesting things. All we are doing right now is and then you see the diamond block, you just drop that. See that? It lights up. I don't know if you can see, but as I bring this block, this decision block closer and closer and closer to the if then, that lights up and I drop it there. Then what you can do, Excuse me. So if touching the paddle, because the paddle was created as a sprite, so it's going to ask you, hey, if, and you're already inside the ball, right? You're programming to the ball, so the ball should not be available in the drop down. If there was, then that's faulty, right? You can't. You're already programming the ball, so the ball can only touch other things. The ball can touch the edge, the ball can touch the mouse pointer, or the ball can touch any other sprite that is available. In our case, that is the paddle. So that's how you choose the paddle, right? So far, so good, right? So then I'm just showing you how the program is developed, right? Side by side. Then you want to start a sound. And the sound that I wanted to play was the water drop. You notice, right? The little thing that you heard, that sound, it's called the water drop sound that was available. I thought that was a good sound. You can choose other sounds. So now, so far, so good. You know, when you click the flag, you want to start the game. Now, this is also triggered already. So when you start the flag, when you click the flag, this logic is already complete. The ball is going to keep, the ball is going to come from this angle at 45 degrees from this location, XY location. And if it hits the edge, it's going to bounce and it's going to keep moving 10 steps at a time. So that's done. That logic is done. And then this logic, now you're programming this logic to the ball, is all about when it touches the paddle, that's this part. When it touches the paddle, you're making that water drop sound. Okay, simple, right? Then you also got to make sure that the ball bounces, right? What do you do? How do you bounce it? So remember I said you could do different ways. So here what I'm doing is, I could do it exact physics and detect the angle at which the ball is coming, and then decide that if it's a reflection, what's the angle it's going to reflect. So that's how these things work, right? If it comes, follow my mouse, right? If it comes at this angle like that, when it hits, it's going to bounce at an equal angle from the vertical in this direction, right? It comes this way, the ball comes this way, it's going to bounce exactly this way, right? Of course, you can bring in real physics and say the ground is rough or the wall is rough, and then you can make it bounce at a totally different angle, saying that it's not smooth and so on. So, however, right? So I just said it's very simple. I'm going to make the ball turn. I'm going to make the ball turn, and rather than go the default 15 degrees, you can go to what is called as an operator. And the operator, right? You can compare, you can add stuff, divide, multiply, or there is an interesting operator that's called random. And I just dropped that random operator and said, I always want it to, because it's going to bounce upwards, right? It's not coming down. And remember, the angles are from the vertical. If you ever have a doubt, you can always go here and see the angles here are from the vertical. So I wanted it to bounce back up, right? I know the paddle is on the floor and I want it to bounce back up, which gives me this, movement, right? The angles that I'm interested in. So I said, I'm going to fix that to about 160 to 200 degrees. In that range, I'm going to bounce it. So I'm always going to bounce it in that range, but I'm going to pick a little bit of randomness to account for the fact that there might be so those kinds of things you can do. So it's pretty simple behavior. And I'm going to continue to move the ball 10 steps. I should not stop moving the ball. So added that. So far, so good, right? When the flag is clicked, we know that this logic is all set. It's working. Here in the forever loop, I'm seeing if the ball and the paddle are touching each other. If they touch, I want to make that water drop sound. And then what happens if it touches? Not just make the sound. I want to turn the ball around, pick a random 160 to 200 degrees. And why did I pick this? Because it would look weird if the ball is not bouncing back up. And because this starts at 0, the vertical, and then you saw that this was 45, then 90 was this, and 120 would be in another angle. Choosing this makes it more realistic, and then I move the ball. So that completely takes care of the motion of the ball in a very realistic manner if it touches the paddle. Now, if you don't want the game to stop, you're done. But if you want to also, if the ball slips through the paddle, then you could say if it touches the sidewalk or if it touches a red color, so then you can go to the if control, add one more if condition, and say this. Remember, this if condition should not be nested here. It's very different if you put this if over here inside versus if this is outside this condition, because this is only to do with the paddle touching the ball. You need to bounce. But there is a totally different if condition where if you were to touch a certain color, then you want it to basically, whatever color you pick, we can pick black. Makes it easy, right? Then black is everything is 0, 0, 0, right? That's black. White would be the opposite. White would be the total opposite. Okay, it's 100, 100, 100. Okay, so like I said, right, you can play around with the numbers that they provide in Scratch, and you can figure out your colors. But if it touches black or red or whatever color you choose, you want to stop everything. So if you want to stop everything, you want to choose that. Now here also, right, you can do fun stuff. You can stop just something. You can stop this script. You can stop a script in another sprite. You have a control over various things, right? For example, you want to only take one sprite out of the game. So you could say hide this sprite and stop some logic. So that way you don't affect the rest of the code. You could continue to execute other parts of the code. So you don't have to stop all. You can stop this sprite and take it out of the game, or you can stop some particular script in the sprite. That's all possible. Okay. So here we are stopping all. So, and I put black color. So then I could go to the costume. I could create, let me create a new, I have to create a new costume. Okay. So I'll create a new sprite, paint, and I could say fill it all black. And I could draw this, bring it here, the bottom, but the paddle is also black. Let's see if let's see if that's going to interfere. It could. Let's see what happens. And so this stopped. So when it hits the floor, it stopped. Only thing is, let's see what happens if it hits the paddle. Okay, the paddle is a different hue. It is not exactly the 100, 100, 100. Like I said, the colors are based on numbers, and it has to be exact. So, but it hit the floor, it stopped. So the paddle's hue is a little different. It's not the 100, 100, 100 that was the total black. This is probably a shade that's a little bit lighter than this. One of the numbers is not 100, right? It could be 98, in which case the program will not consider it the same color. So that's the beauty of this. So it's not considering the same color, but you saw basically the program stopped when it hit that color. So again, pretty simple, right? So we have basically completed the whole game. Now I'm going to get rid of this. We can always change this color to black too. So then it should be fine. I'm going to get rid of this. And there you have your game. Very simple game. We first programmed the paddle to just move around, move around in the X direction. And then we said that, the ball, programmed the ball and said, hey, let the ball keep bouncing and go in this angle, start off that way. And then when the ball touches the paddle, create a sound and then pick this random angle between this 160 to 200 and bounce the ball back. And then if the ball touches the sidewalk or whatever this color is, then make sure that you stop the game, right? Pretty simple logic. And then you can change the background, right? So hopefully, so let me get back to the presentation and then cover a few other concepts, right? Because we won't be able to do a lot of games, right? This game was somewhat easier to program. We could do this in about 40 minutes. But let me share some concepts with you. So angle, right? If you're not familiar with it, some of you might be already. The vertex, the ray, the angle is between two rays, and then 30 degrees, 120 degrees, and so on, 90 degrees. So you got to really familiarize yourself with a lot of geometry, math, and physics if you want to program realistic games. So these are all definitions. You can look them up. What is a vertex? What is a ray? What's an angle? I'm sure most of you already know it. So, and then of course, we did the lab for Pong. Then I also want to share some tricks with you. If you're going to do a shooting game, a jumping game, a maze game, right? So this game was called Prince of Persia. Very, very popular game. Or Asteroids. And this is called Digger. So there are all these games that were really simply amazing games. This is like a maze game, whereas this is a platform game. The Prince of Persia was a platform game. And this is just a shooting game. The Asteroids, basically you have a little asteroid, you have a little spaceship in the middle, if you can see. And this was just a black and white game where the asteroids are coming towards you and you could fire and shoot things, right? So I'm going to show you, this is an interesting game, the shooting game, right? I'm going to show you how you can make something shoot. Let me show you a couple of tricks. There's no time to program it, but I'm going to show you how you can create such a game, right? What is the simple logic? I'm going to show you that. So here is a simple shooting script. So I have this, plane, right? So you see, I can basically, so I can rotate and shoot. See how the plane shoots. Now this sprite is something I created from the outside and brought it in because you won't find this. But I'm essentially, there are two sprites and there are logic associated with the bullet or the missile. So that when I hit the space bar, when the space key is pressed, wherever the sprite 1, which is the spaceship is pointed towards, I'm firing. And then the bullet disappears when it hits the edge. It doesn't bounce and come back and so on. And then I'm hiding it. I'm usually hiding it until and unless I click the space bar. That's why you don't see the bullet constantly around. Otherwise, this sprite is not seen. And then when I click the space bar, it fires and goes all the way across, right? So this is a little effect you can create. And a lot of these you can reuse. As you start programming games, you'll have a repository or a bunch of these common functions you can simply drag and drop and reuse because you need it in different parts of the game or in different games. And this logic is very simple. Here I'm using the left arrow or the right arrow, and each time I press the left or right arrow, I'm turning either anti-clockwise or clockwise, and you can see my spaceship turning. Now imagine combining this with pressing the space bar allows me to shoot, right? So this is very similar to how the Asteroids game was built. Now you can add to this and you can have the asteroid sprites, trying to hurtle towards the spacecraft. And then when you fire and the missile hits the asteroid, you can smash it to smithereens, right? So that's kind of easy to program this game. So, and then of course, you can create your maze, you can create platform games. In the platform games, you can, detect jumps. When you detect jumps, you got to take care of gravity. So you should be able to think through and build this kind of logic. It'll take you some time, but that's part of learning how to do it, right? So you're learning a lot of the basic concepts today, and these are all the different type of games you can create. And I also want to so there is no time for us to build a shooting game, show you how to fire from that spaceship, but because this is only a 2-hour workshop today. I want to leave you with a little homework, okay? I'm going to show you this game. First, let me show you how this game works, and then that's going to be your homework. So you're going to build this game, and you're going to build it before Halloween, and then you'd be able to share it with your friends and family. It'll take you a couple of months to build. Now, it won't take you a couple of months to build. Just work a couple of hours every weekend, and probably in the next 4 weekends, you should be able to build this, right? 4 or 5 weekends. So it's a fun game. A lot of effects going on. As you can see, it is not just one set of logic. There's going to be a bunch of logic, that you have to build, and I'll walk you through in a second. And there are 3 types of witches, and there is a bat, and so on. So how does this game work, right? Let's click the button. So it says click space to play this game, and there is a score variable, and there is a countdown. There is a timer, a countdown timer. You'll see. I click the witch turns into a frog, and as you can see, I get scores. See, I get scores as I click, and they go fast and slow, and they go randomly, and there's a countdown. How many witches can you click before your timer runs out, right? Some of them are so fast that I'm not able to click. There you go. So basically, this game you play for 30 seconds and you try to, anyway, you can create variations. And essentially, this is the special effects and everything. And you have this spooky place and witches are flying around. Game over because the countdown timer. So it's just a 30-second game, but the 30 seconds can feel like 3 minutes, okay, in the game while you're playing and or sometimes the 30 seconds will seem like 3 seconds if it's a very fast-paced game. But as you can see, right, so this game, you saw how it worked. Now, I want you to create this logic. And let's look at how to design this game, right? I'm going to leave you, take a couple of minutes, and we're going to discuss how to design this game. So here we have labels, right? There are labels all over the place. You saw game over, and you saw get set, ready, set, go. And so those are all labels. So when you start the game and the game is over, you got to create labels, and these labels are moving a little bit. And then you got to switch those labels, hide labels, only show what games are relevant or labels are relevant, and so on, right? Then you obviously have the witch. The witch is flying, and we had 3 different witches, different sizes, different speeds at which they were flying, and so on. And then the costume, the witch itself has the costume of the frog, because once you click the witch and that click is detected, remember we could detect if you were clicking a sprite, then the costume for that witch is converted to a frog, and the frog is animated to fall vertically down from the location at which you clicked all the way to the ground, right? And you saw that frog fall to the ground. So the witch and the frog are one and the same. It's just a different costume. And then you want to hide all the witches. And then you want to, in the pre-game scenes, you don't want to see the witches. Then when you start the game, the witches can fly around at random speeds and set the witches to random sizes. And when you click the witch will change into a frog, and you update the score. Now there is a timer, a variable that's a timer that keeps, counting down, and you got to keep checking if that is 0. Then you have the bat. It just came in the pre-screen, in the pre-game. It didn't come later. It just came in the pre-game. Then you have multiple scenes. First, there was a forest, and then you switch the screens to some other woods for the game, the purple woods, and then you were trying to catch the clicks on the witches. So a lot of stuff going on here, but this is essentially the various sprites that you need, the costumes, the scripts. Now, I have not mentioned the sound and the backdrop and the variables to keep the timer or the score. Those things, you should be able to add using our game design template, and write them all down, and then kind of think through this, then come up with a pseudocode, right? Write in English what the logic is, and then you should be able to create the game. Now, my name is G. Venkat. I'm an educator, a scientist, and an author. And I've been, building Bitwise Academy to bring STEM education to kids. We do, all kinds of STEM courses, right from these kinds of game design all the way to AI and data science and complex courses for, high schoolers and so on. And, visit our website, bitwiseacademy.com. If you visit the website, you'll see a lot of information on various things. We also have things for helping you with homework, simulations and tools for your physics, math, chemistry, and so on. We have assessments and a lot of fun stuff. And if you ever have any question, do write to me, and I'll point you in the right direction to the best of my ability. So my email is venkat@bitwiseacademy.com. Thank you all for attending this from all parts of our various time zones, and also, attending. Some of you attended our live stream on Facebook or YouTube. So really, have a wonderful Sunday, and hope to, see you all, take on various STEM careers and develop an interest. And maybe this game design is just what you need to spark that interest, spark that curiosity. Thank you so much. Have a great day. Bye now.